NCERT Class 9 Chapter 3 Science Atom and Molecules page 42 Q1 and 2. Question number 1. If 1 mole of carbon atoms weighs 12 grams, what is the mass, in grams, of 1 atom of carbon? Solution. Given, 1 mole of carbon weighs 12 grams. 1 mole of carbon atoms is equal to 6.022 times 1023. The molecular mass of carbon atoms equals 12 gram equals an atom of carbon mass. Hence, mass of 1 carbon atom equals 12/6.022 by 10 to the power minus 23 equals 1.99 x 10 to the power minus 23 gram. 2. Which has more number of atoms, 100 grams of sodium or 100 grams of iron, given the atomic mass of Na equals 23U, Fe equals 56U? Solution. A. In 100 grams of Na, M equals 100 gram, molar mass of Na atom equals 23 gram, N0 is equal to 6.022 times 1023. N equals, given mass x N0, / molar mass. N equals, 100 by 6.022 by 1023, / 23. N is equal to 26.18 times 1023 atoms. B. In 100 grams of Fe, M equals 100 g. Molar mass of Fe atom equals 56 g, N0 is equal to 6.022 times 1023, N equals, given mass x N0, / molar mass. N equals, 100 by 6.022 by 1023, / 56. N is equal to 10.75 times 1023 atoms. Therefore, the number of atoms is more in 100 g of Na than in 100 g of Fe. Question number 1. A 0.24 gram sample of a compound of oxygen and boron was found by analysis to contain 0.096 gram of boron and 0.144 gram of oxygen. Calculate the percentage composition of the compound by weight. Solution. Given, mass of the sample compound equals 0.24 gram, mass of boron equals 0.096 gram, mass of oxygen equals 0.144 gram. To calculate the percentage composition of the compound, percentage of boron equals mass of boron divided by mass of the compound multiple 100 equals 0.096 g divided by 0.24 g multiple 100 equals 40%. Percentage of oxygen equals 100 minus percentage of boron equals 100 minus 40 equals 60%. Question number 2. When 3.0 gram of carbon is burned and 8.00 gram of oxygen, 11.00 gram of carbon dioxide is produced. What mass of carbon dioxide will be formed when 3.00 gram of carbon is burnt and 50.00 gram of oxygen? Which law of chemical combination will govern your answer? Solution. When 3.0 gram of carbon is burnt and 8.00 g of oxygen, 11.00 gram of carbon dioxide is produced. Given that 3.0 gram of carbon combines with 8.0 gram of oxygen to give 11.0 gram of carbon dioxide. Find out. We need to find out the mass of carbon dioxide that will be formed when 3.00 gram of carbon is burnt in 50.00 gram of oxygen. First, let us write the reaction taking place here. C plus O2, CO2. As per the given condition, when 3.0 gram of carbon is burned in 8.00 g of oxygen, 11.00 gram of carbon dioxide is produced. 3 gram plus 8 gram 11 gram from the above reaction. The total mass of reactants equals mass of carbon plus mass of oxygen equals 3 gram plus 8 gram equals 11 gram. Mass of reactants equals total mass of products. Therefore, the law of conservation of mass is proved. Then, it also depicts that carbon dioxide contains carbon and oxygen in a fixed ratio by mass, which is 3:8. Thus, it further proves the law of constant proportions. 3 gram of carbon must also combine with 8 gram of oxygen only. This means that 50 minus 8 equals 42 gram of oxygen will remain unreacted. The remaining 42 gram of oxygen will be left unreactive. In this case, too, only 11 gram of carbon dioxide will be formed. The above answer is governed by the law of constant proportions. Question number 3. What are polyatomic ions? Give examples. Solution. Polyatomic ions are ions that contain more than one atom, but they behave as a single unit. Example, CO3. 2 negative ion. H2PO 4 negative ion. Question number 4. Write the chemical formula of the following. A. Magnesium chloride. B. Calcium oxide. C. Copper nitrate. D. Aluminium chloride. E. Calcium carbonate. Solution. The following are the chemical formula of the above-mentioned list. A. Magnesium chloride, MgCl2. B. Calcium oxide, CaO. C. Copper nitrate, CuNO32. D. Aluminium chloride, AlCl3. E. Calcium carbonate, CaCO3. Solution. The following are the chemical formula of the above-mentioned list. A. Magnesium chloride, MgCl2. B. Calcium oxide, CaO. C. Copper nitrate, CuNO32. D. Aluminium chloride, AlCl3. E. Calcium carbonate, CaCO3. Calculate the molar mass of the following substances. A. Ethene, C2H2. B. Sulfur molecule, S8. C. Phosphorus molecule, P4, atomic mass of phosphorus equals 31. D. Hydrochloric acid, HCl. E. Nitric acid, HNO3. Solution. Listed below is the molar mass of the following substances. A. Molar mass of ethene C2H2 equals 2 multiple mass of carbon plus 2 multiple mass of hydrogen equals 2 multiple 12 plus 2 multiple 1 equals 24 plus 2 equals 26 gram. B. Molar mass of sulfur molecule S8 equals 8x mass of S is equal to 8 times 32 equals 256 g. C. Molar mass of phosphorus molecule, P4 equals 4x mass of P is equal to 4 times 31 equals 124 g. D. Molar mass of hydrochloric acid, HCl equals mass of H plus mass of Cl equals 1 plus 35.5 equals 36.5 g. E. Molar mass of nitric acid, HNO3 equals mass of H plus mass of nitrogen, plus 3x mass of O equals 1 plus 14 plus 3 times 16 is equal to 63 G. Question number 7. What is the mass of A. 1 mole of nitrogen atoms? B. For moles of aluminium atoms, atomic mass of aluminium equals 27? C. 10 moles of sodium sulfite, Na2SO3? Solution. The mass of the above-mentioned list is as follows. A. Atomic mass of nitrogen atoms equals 14 U. Mass of 1 mole of nitrogen atoms equals atomic mass of nitrogen atoms. Therefore, the mass of 1 mole of nitrogen atom is 14 G. B. Atomic mass of aluminium equals 27 U. Mass of 1 mole of aluminium atoms equals 27 G. 1 mole of aluminium atoms equals 27 G. For moles of aluminium atoms is equal to 4 times 27 equals 108 G. C. Mass of 1 mole of sodium sulfite Na2SO3 equals molecular mass of sodium sulfite equals 2x mass of Na plus mass of S plus 3. X mass of O equals 2 by 23 plus 32 plus 3x16 equals 46 plus 32 plus 48 equals 126 G. Therefore, mass of 10 moles of Na2SO3 is equal to 10 times 126 equals 1260 G. 8. Convert into a mole. A. 12 G of oxygen gas. B. 20 G of water. C. 22 G of carbon dioxide. Solution. Conversion of the above-mentioned molecules into moles is as follows. A. Given, mass of oxygen gas equals 12 G. Molar mass of oxygen gas equals 2 mass of oxygen is equal to 2 times 16 equals 32 G. Number of moles equals mass given / molar mass of oxygen gas equals 12/30 seconds equals 0.375 moles. B. Given, mass of water equals 20 G. Molar mass of water equals 2x mass of hydrogen, plus mass of oxygen, is equal to 2 times 1, plus 16 equals 18 G. Number of moles equals mass given / molar mass of water. Equals 20/18 equals 1.11 moles. C. Given, mass of carbon dioxide equals 22 G. Molar mass of carbon dioxide equals mass of C plus 2x mass of oxygen equals 12 plus 2x16 equals 12 plus 32 equals 44 G. Number of moles equals mass given / molar mass of carbon dioxide equals 22/44 equals 0.5 moles. Question number 9. What is the mass of A. 0.2 mole of oxygen atoms? B. 0.5 mole of water molecule? Solution. The mass is as follows. A. Mass of 1 mole of oxygen atoms equals 16 U, hence, it weighs 16 G. Mass of 0.2 moles of oxygen atoms is equal to 0.2 times 16 equals 3.2 G. B. Mass of 1 mole of water molecules equals 18 U, hence, it weighs 18 G. Mass of 0.5 moles of water molecules is equal to 0.5 times 18 equals 9 G. 10. Calculate the number of molecules of sulfur, S8, present in 16 G of solid sulfur. Solution. To calculate the molecular mass of sulfur, S8, equals 8x mass of sulfur is equal to 8 times 32 equals 256 g. Mass given equals 16 g. Number of moles equals mass given / molar mass of sulfur equals 16 divided by 256 is equal to 0.0625 moles. To calculate the number of molecules of sulfur in 16 g of solid sulfur, number of molecules equals number of moles x Avogadro number equals 0.0625 x 6.022 x 10 superscript 2 superscript 3 molecules is equal to 3.763 times 1022 molecules. 11. Calculate the number of aluminium ions present in 0.051 g of aluminium oxide. Hint: the mass of an ion is the same as that of an atom of the same element. Atomic mass of Al equals 27 U. Solution: to calculate the number of aluminium ions in 0.051 g of aluminium oxide, 1 mole of aluminium oxide is equal to 6.022 times 1023 molecules of aluminium oxide. 1 mole of aluminium oxide, Al2O3, equals 2x mass of aluminium plus 3x mass of oxygen. Equals 2x27 plus 3 by 16 equals 54 plus 48 equals 102 g. 1 mole of aluminium oxide equals 102 g is equal to 6.022 times 1023 molecules of aluminium oxide. Therefore, 0.051 g of aluminium oxide has is equal to 6.022 times 1023/102 by 0.051 is equal to 3.011 times 1020 molecules of aluminium oxide. 1 molecule of aluminium oxide has 2 aluminium ions, hence, the number of aluminium ions present in 0.051 g of aluminium oxide is equal to 2 times 3.011 times 1020 molecules of aluminium oxide is equal to 6.022 times 1020. Please like, subscribe, and comment.